Can you hear us on Zoom? No complaint. No, impossible. Hello. Hello. How are you? It's a long time. It's so pretty. You're right. Ça va. You make it attractive to the room. It's nice. Did you see it? No. So I want to show you. I won't go for long. We started together. Hello everybody, we'll start. It's a great pleasure for me to present today Agnes Kovacs, because we have the same mentor, Jacques Peller, and I discovered Agnes works a long time ago, not so long, because otherwise they would think that we are old, but she worked at that time on bilingualism, and she has a very nice paper on in science and PNIs showing that indeed we may have some advantage to be bilingual, which is maybe current in Hungary, because we are from Hungary. In France, we are like Christophe and I, rather monolingual. But still, bilingualism is a very important topic, and she shows in particular that you gain from to be bilingual, you have more cognitive flexibility, and you can find cues for that already in infants, that bilingual infants are able to switch from one task to another one, because in fact, in their daily lives, they are used to switch from one language to the other one. After that, she spent quite some time in Italy, go back to Hungary in Budapest, in the famous, I never remember, Central European University. You may know this university because there were some troubles, and it reminds us that academic freedom is a fight, because this academy was, this university was granted by Soros, and Orban, as you know, who is Hungarian president, does not like some people and like others, and it's quite, I don't know what is your opinion, so I will not say anything, but you know that they were obliged to go away to Vienna. So fortunately, Vienna opened a place for the university to be hosted in Vienna. But I just learned that now you have both sides, so that maybe there's maybe more, or well, we will discuss politics after that. Right? So now you have two very large in two countries. So it's and you go on working no more on bilingualism, but maybe now that you have two countries, you can make bilingual studies, but more on something which are great interest for us, which is symbols. Language is by definition a combination of symbols, but you have also symbols in mathematics, so it interests us, and many other domains in geometry. I see Lorenzo working on geometry, and I see many other people working on different aspects of symbols. But what Agnes is doing is in babies, and to show where does this symbolic mind come from. Is that present from very early on? What does it mean to have a symbolic mind? Does it mean that we can combine property and make some operation, like also negation? So I read that in your abstract. So I am very interested by that because I'm working a little bit on the same topic. So we'll discuss on that. So Agnes is a very prolific and very important researcher in development. So I am sure that she will convince you once again that babies are the most interesting for toddlers, because you are a little bit older than me, are a very important population to study, because it will give us insight about how the adult brain is also working, and adult mind is also working. So thank you, Agnes, to come from Vienna to here, to spend some time in Paris. And if you want to discuss on this topic with Agnes this afternoon, there is a BBC with Julie, who is organizing all the meeting. Thank you, Agnes, and I give you the floor.
Thank you very much. Thank you very much for this very nice introduction, and I'm very happy to be here. I will talk today about a topic which might be of interest to many of you here, but it's of great interest to me. And it's on the origin of abstract combinatorial thought, and we will ask the question how we compose meaning in infancy. As Ghislaine mentioned, I don't study very young infants, especially in this research which I will present today. These are infants who are, let's say, 12 months old or 18 months old, so they are a little bit between infancy and toddlerhood. However, there are some questions which can be asked only with this kind of infants and this kind of population, infants and toddlers. And I hope, I'm looking very much forward to see what you think of the arguments and of the results which I will present. Okay. So let us start from this wonderful picture, which is a simple picture of domino cards. And while in the last decades we have gained lots of knowledge about how we represent different objects and how the human mind makes sense of the environment. And we know a lot about object tracking. We know a lot about how we represent numerosities, especially from work done here. However, what I will focus today and what we know much less about is actually this kind of entities, which in this case is actually representing absence. So if we consider this part of the domino, which has no dots, how do we represent it? So how do we represent the absence of something? So we can represent it, of course, in many ways. We can just think, oh, this is the empty side of the domino. We can think that this is the side which has no dots. But remember that if we perform this kind of operation, or we can represent it as a 0 dots, right? The side with the 0 dots. But remember, if we do this kind of representations, these are highly complex representations, right? Which go much beyond object tracking, and it involves some kind of concept composition, right? So you either use negation to say there are no dots on these sides of domino, or you use quantification like 0 dots. And of course, the question which interests me is how very young infants go beyond the here and now and arrive to represent entities which are not so trivial to grasp, right? Which in this case, they are not present. So here you have to form a representation based on the absence of a stimuli, right? And the question is, how do we do that? And what are the operations and representation which might allow you to do that in early infancy? Of course, young infants have to form also other kinds of representations, which are also non-trivial in the sense that it's not always that we can see and we can perceive all information which is available to us. Oftentimes, we have to infer information based on what we see. But this information which we infer is actually not present in the stimuli, right? So, and this, a beautiful example comes actually from Ghislaine's work with Milad. So, for instance, they have shown that very young infants can use disjunctive syllogism, very complex operations, to infer, to learn about the environment. So probably you are very familiar with this task, but let me just mention it simple. So you have this, these two faces, and you hear a voice, let's say a female voice talking. And then, of course, you have to map the voice to the face. So how do you do it? So you have no idea. It can be face 1, face 2. How do you know which one is the female? You don't know. It can be either A, either B. Then, however, you can make the inference, you can identify which one was the talking face based on later evidence. So if later on you show one single face and talking in a different voice, let's say male voice, then based on this evidence, you can make an inference about which one could have been the female, right? You go back in time and you figure out, so it's the female could be A or B. It is not A because A is the male, therefore it must be B. And seemingly, infants are very good in performing such operations. We know that from the work of Milad, also from the work of Niccolò Cesaraliotti, and also some of our work. Together with Niccolò, in which we show not only that babies make these non-trivial inferences and they can make, they can infer the identity of objects, for instance, based on this disjunctive syllogism and negation, right? Because when you say A or B, not A, then you negate the A in order to make an inference about the B. But you can also use these to integrate them in further computations. In this specific case, which I'm presenting it here, you can integrate it to infer the goal of a person. So you take something from the an inference which you make based on objects, and you make social inferences based on these junctions. So you integrate it in a fully different domain, which also shows something about the power of these computations present early on. These were, in our case, they were 14 months old. I think in Milad's case, they were 9 or 10 months old, younger infants. And of course, infants, and of course we as adults also have to make other kinds of inferences which are about the social world. And there again, you have to make very non-trivial inferences, right? So we make inferences about the goals, the beliefs of other people. And these are, again, non-observable, right? So you have to infer them. You cannot observe a goal. You cannot observe a belief of another person. However, what we have found is that very young infants, not only that they can infer a belief of a person, but they actually store the information which resulted in this belief, the reason for this belief, and in a causal chain. And this allows them to update this belief, right? Because you can update others' beliefs as well as your own beliefs only if you store the reason for the belief, because if that reason changes, then also you have to change the belief. And we also find evidence in 18 months that infants are able to do that. And of course, there are also other cases where we interpret, for instance, the actions of other people, which can be simple instrumental actions like me grasping this telephone, or it can be also other kinds of actions where not only the goal is not observable, but also the end state is non-observable, and these are the epistemic actions, right? What is an epistemic action? Is an action which leads to information, but the result of that is, again, non-observable. And we also have evidence with Balint Varga that young infants at 14 months, they can also interpret others' epistemic actions where the goal is opaque and the end state is opaque, because both of them are non-visible and non-instrumental and non-directly observable. However, they seemingly can make these powerful inferences. Okay, but today I will talk about only one part of this whole enterprise, and mostly about composition and negation in infants and toddlers. And when we think of composition, when we talk about the adult mind, we, of course, think that the adult mind has unbounded capacities. We can take any concepts which we have, we combine them in novel ways, and we arrive to novel concepts, right? The question, of course, emerges, so where does this ability come from? Is there, and one crucial question which always emerges in the literature, is whether language is necessary for such kind of computations to emerge, right? So according to one view, language is a precondition for such compositional abilities, and language fosters forming abstract concepts. Of course, language is a natural candidate because language is compositional by definition, right? So we take the words and we can form any kind of proposition based on these combinations. Okay, so if language, according to one view, it's extensive experience with natural language, which allows young children to form complex combinations. However, this also has the implication that before language, they would have some proto or some minimal representations. They won't have abstract representation and proto operators. However, there's also the other view, which is the language of thought, which is before or outside language. According to this view, there are combinatorial abilities very early on and abstract concepts, and language it makes use of these abilities, in fact. And it allows, and these abilities, maybe they are the ones which allow for learning language. And this comes with the presupposition that young infants, already before language or at the onset of language, they should possess this concept. And also this comes with the implications that if language is not necessary, then of course there can be these operations and these representations can emerge in various domains, like work by Stan and collaborators has shown that we can have a language of geometry, language of music, and other languages of thought. And of course, a crucial question is whether, if language is not necessary, then would other animals and other species would have access to such representations and such abilities. So here I put like a kind of summary of what I think which would be the crucial representations and the crucial operations, which would show that young infants have some abstract concepts and some combinatorial operations. I will just mention a couple of them. Probably many of them, they are familiar to you. So young infants do have abstract categories of kinds, thematic laws, maybe symbols. They do have, their knowledge is semantically organized already before their first birthday. They have core knowledge in different domains. And of course, they also have access to different operations. There's evidence that they can learn algebraic-like rules and they match them to symbols. They can do some disjunction and negation, as we have seen in Milad and the Niccolo studies. However, there is also some negative evidence, according to which there's no evidence that they can do function composition. So in this talk, I will present a series of studies in which we try to address compositionality in language, outside the language, negation in language, outside language. And in the very end, I will talk about a new line of studies in which we try to investigate whether infants have a scene gist. But let me start with the very first study. So this study was done in collaboration, it was run actually by Barbara Pomyakowska and Gabor. And what we are interested in, okay, so if young infants have these compositional operations, then they should be able to combine a newly learned concept or a newly learned label or symbol with something old, right? So why did we try to go in this direction, and why don't we take evidence that that if at 12 months a young child understands, for instance, pretty baby, which is a composition of pretty and baby, wouldn't we say that this is evidence for composition or not? Or if a young child understands, I don't know, oh, gone, wouldn't this be composition? However, while we think of language as naturally compositional, this is not the major view in the literature. So according to the major view in the literature, the early sentences which the infants learn or the infants can interpret, there might not be compositional in the sense that they might be like islands, like word islands, which you learn by association. So you learn by association pretty baby, but you don't decompose and you cannot understand pretty dog or pretty dinosaur. So you won't be able to understand this concept, even though you would understand dinosaur, because you treat pretty baby as a unit. Okay. If this is the case, how can we ever measure using linguistic stimuli whether babies have can do composition? And what we came up was the idea to actually teach them a novel concept, well, not a novel concept, but a novel symbol, which in this case was a word, and then see whether they can take this novel concept, which they never heard, so they cannot rely on these associations, right? That you have the context and you just retrieve from memory all these kind of combinations. So we teach them something novel and we check whether they can combine it with something which they know. And this is exactly what we did. So what we tried to teach them were actually numerical or quantity-related concepts, and we tried to teach them a word for one and a word for two. These are non-words. This study was done in Hungary, and we said mize, which means nothing in Hungarian, for two, and let's say kabo for one, and we tell them, well, this is kabo duck, meaning that this is one duck, and we had repeated exemplars for that. And the idea was that we teach them these quantity-related labels, and together with some nouns and some object labels which they know. And then we take some new labels, new kind labels. So if we use, for instance, ducks in the familiarization, then we will use dogs in the test. And we will test whether they can actually combine this newly learned symbolic representation with something which they know. And this is exactly what we did. So the study is really simple. We teach them these two new labels for one and two, and then we test them. They never seen dog in this experiment before, and we show them two dogs, and we tell them, look, miss a dog, and we measure whether they look at the target, which is in this case among other distractors, which can be of different kind. And of course, you can combine a new concept with something old only if you have both concepts, right? So we also checked whether they can learn this one and two in a separate experiment, but also we have to check whether they know the word dog, right? They can map the label dog to the respective object. And we had, in the end of the study, we had like a kind test. We checked whether they know the words for the objects which we use in test. And then we separated the infants in kind knowers and non-kind knowers. Of course, we expect positive results only from those who know the kind labels, right? Because those who don't know, even if they learn the new concept, they learn mize, what it means, they don't know dog, how they could combine it, right? And this is what we checked, and this is what we find, that those who know the kinds, these are the kinds, here I mean the labels for the test objects, like dog and duck and whatever we have used, those do successfully combine. So here they look longer when we tell them mize dog, which means two dogs. They look successfully to the target compared to the other three distractors. However, those who don't know the name dog, they are a chance in all conditions. Okay, so this is some evidence that they actually they can learn a new symbol, let's say, in this case for the two, and they can combine it with something old. But the question, of course, and the interesting question is always, how do they do that? So how do they learn that? Do they use adult-like composition, which is hierarchical and fully-fledged compositional abilities, or do they use some simple mechanisms? And what can be here the simple mechanism? So assuming then they learned mize for two, then what they can do, they can actually search for items which fulfill the criteria for mize, which is in this case two. So this set fulfills the criteria for mize, this as well, and this as well. And they can also, when they hear duck, then also they check which one fulfills the criteria for duck. So they can do a kind of parallel search without combining this mesa duck, which means two duck, in any way. So if they do that, then what is the prediction? You see that this very weird stimuli, which we have here, which we call the mixed distractor. And we introduced this mixed distractor exactly for this reason, to check whether infants use a lower level, like a proto-composition. They just do parallel search, and whatever is good for, they find a matching item for 2, something which matches duck, and then they just check for what satisfies both criteria without composing the two concepts. Or they do the adult-like composition, where actually there are 2 ducks, where 2 is a modifier applied to the duck. And what we find that young infants, these are again 12 months old, they do, even in this case, where they have this possibility to go for this mixed distractor, which would fulfill the criteria for this parallel search, they don't do it. Meaning, from which we conclude that they don't apply this parallel search strategy or this proto-compositionality, but they do fully adult-like compositionality, and they find the target. Okay, so this is just the time course of the looking behavior. So this was, I forgot to mention that this was an eye tracking study, but it doesn't matter. It could have been also preferential looking, because we just measure whether they find the referent, whether in that case. Okay, so what we have seen here, that they show adult-like compositionality, which involves this newly learned label and a known label. But of course, some compositional relations are one way, right? So 2 dog is composed in a very specific way, but other relations can be reversible, where, and we were interested whether at some age, and these are even older infants, let's call them toddlers. So I will use this infant and toddler a little bit as synonyms, but please bear with me. So we were interested whether infants can also encode these reversible relations and compose them based on what they hear. And this is again a language study, and that's why we have to use older children, right? Toddlers, these are 20 months, because they have to have some knowledge of language. Otherwise, we cannot test them with linguistic stimuli. So here, if I tell them a sentence like "the box is in the bucket," or "the bucket is in the box," they have to understand bucket, box, and they have to understand in as well, and they have to map all these to language and combine it in a specific way. So we went for older infants, because only at 15 months we have some evidence for decomposition in Hungarian, which is not even a prefix, but it's a suffix. So it attaches to one of the nouns, as you see here. So it's a vödörben, which means in the bucket. And what we find here, that indeed language knowledge plays a role. Of course, you have to solve this mapping issue, and this mapping issue will come back over and over, that whenever we study language, we do have this mapping issue. So what we find here, that only those infants who have a high vocabulary, they are above chance. And when I tell them bucket in the box, they look to the correct answer, and box in the bucket, then they switch to the other. But however, at least at this age, we do find some evidence in some group of infants. Of course, if we take this as evidence for compositionality, then one should argue that if early on, let's say at 12 months, they already can compose this concept with, when we use linguistic stimuli, then one should assume that this ability should be present much earlier, and we should find them also in the non-linguistic domain, right? So it should not be specific to language, likely. However, there is one previous study which we are aware of, which shows that actually, if you take function composition with non-linguistic stimuli, so this is an experiment where you have this disk which goes beyond an occluder, and there are 2 function modifiers, this red thing and this dotted thing. So if you put the red thing on the occluder, then it changes the object's sides to red. So it applies red to this object, that's the function. And if you put this dotted thing to the occluder, then when the object goes behind the occluder, then it becomes dotted. And of course, what these authors have done, Steve Piantadosi and Richard Aslin, then they put the two functions together, and then they check whether infants can combine and expect that now this object should be both red and dotted. However, what they find is actually no evidence for composition. They find more a pattern which would be similar to one function, to applying only one function. And if infants seem to expect the second function to apply, and they don't combine these two functions. However, as you might notice, these are not very easy stimuli, right? So color is not very salient early in infancy. Pattern is not very salient early in infancy. Also, infants have to understand that this goes there and then it changes the whole thing. So maybe this is not something very easy for the infants to understand. And therefore, what we thought, to do it in a different way, the very similar, so the study which I will present now has a very similar logic. However, we use some stimuli in which we use functions, in the sense that a human hand has an intervention which then results in a function about which we know that infants pay lots of attention on functions. They categorize based on functions, and these artifacts and how they function, they are very important in human culture. So maybe infants would pay, maybe such stimuli would be more salient, and maybe they would succeed. So these are 15 months infants. This is again work with Basha. And what we have done is very simple. So we take an object, which is a duck, then we place this machine on this object, and then we show one function, like we do one manipulation. We manipulate this part of the object, which results in a kind change. So this object turns into another object, or we manipulate the other part of this function object. We show a different kind of action, and which results in a duplication. And of course, we were interested first whether they can learn these two functions separately. And of course, afterwards, we can show these two functions together to ask the question whether they do combine these functions. And also we can get rid of this sequentiality issue, which was present in the Piantadosi study, that you have first one function, then the other. Here we have both functions together. Maybe it doesn't matter, but let me just try to show you a stimuli. I hope it works. So this will be the test. So they see this object, then they see this other object placed on it, and then they see the two kinds of manipulation. One is just rotating. So the actions are different and the manipulations are different. And then what happens, then you see this combined function. So as I said, one of these manipulation changes the kind and the other duplicates the object, and this is the correct outcome. However, and then we compare it with so this is the correct outcome, which is composition congruent, and we compare it with the composition incongruent outcome. However, of course, so in this study, we made our life really hard. I don't know why we do it. Maybe we like to do it, the things in the hard way. But let me tell you why we did it. So here we have an issue. So the infants never saw these two balls as an outcome, right? So they always, in familiation, they saw one ball and two ducks. However, when we compare it, the combined function with one of the functions, by definition, since we teach them one of the functions, it's a familiar outcome. So we have this perceptual problem that one of the things we show them is perceptually novel, but the other is perceptually familiar, right? And we have an imbalance in the stimuli. So we didn't do it to make our life harder, but we did it because we wanted to ask this generalization question, right? So we wanted to see whether infants can combine two functions, and which results in an outcome which they never seen, right? So we didn't want them just to map it to something which was seen before. So it was very important to have novel stimuli in this case, because we want to address this very question whether we can arrive from old concepts to completely new concepts, new in the sense that they never seen this combination. So that's why we made our life difficult, but this resulted in this perceptual novelty. And why I'm telling you this, because perceptual novelty always has an effect. So for instance, they will, if I just show, and for that, how did we overcome this? So for that, we just did a baseline to measure this perceptual novelty. And then the logic was the following. So we measure perceptual novelty, and we expected, so this is a looking time study. I'm not sure how much familiar you are with looking time studies, but most often what is expected, that you have an expected outcome, you look a little because you're not surprised. You have a non-expected outcome, you look a lot. In this case, if we just talk about baseline, forget compositionality, then what is the non-expected outcome here? Well, it's the perceptually novel, right? You've never seen two balls in this setup and in this experiment. So you as an infant, you should look long to this outcome. And however, this should be independent of what I show you before, right? Whether I show you what enters the computations or whether I show you the manipulations. If this is all what matters, then you look long to that. And this is what we did. So we did a baseline where we measured this perceptual effect, and then we did the function composition, and we expected a modulation from this baseline. So if they look, let me explain you better here. So this is the baseline. As we said, the 2-DAX outcome is the familiar. They have seen it in familiarization because it's the outcome of one of the operators. However, the 2-ball outcome, they never seen it. And this is the perceptual novelty effect. And there was no composition here. They didn't see the DAC entering, and they didn't see the manipulation. This is just revealing this outcome. And then we do the composition, and the logic is if composition matters and if they can combine the two functions, then we should see a decrease in this novelty effect, right? The composition congruent outcome should become now more familiar or more expected. Therefore, this blue bar should decrease, and there should be an interaction between these conditions. And this is what we find, which we take as evidence congruent with this composition congruent, but it's based on the interaction between these two experiments because we have this perceptual issue. Now we are replicating this in a different way. At that time, we couldn't think of another way to do it, just to provide more evidence for conceptual combination. Okay, now I see I'm quite late with the time, but I still want to talk about many studies with you. Now I will switch to negation and to how we represent negations. And of course, negation is very important for the same reason. So negation first is an abstract concept, right? You have to understand what it is, but it's also an operator, right? Which can be interpreted only in combination with other elements in language, right? If I tell you this is not a telephone, then you have to interpret it together with the argument to which it applies. And it's by nature compositional. However, there is a very important issue, right? Because here you don't only combine two elements, but one of them is really abstract in the sense that all it does is switches the truth function, right? The negation operator switches the truth function of a proposition. So it's a very important operation, which is inherently compositional. However, it's very difficult to tackle, and it's a question, how can we study it? Okay, but let me start with this present and absence, and let me just tell you about a study which shows that while in infancy we have lots of evidence that infants can encode very well the presence of objects. So if I take this telephone, I hide it, and then I go away and I have nothing in my hand, the babies are surprised, right? Because they encoded that this object should be there. Maybe via object files or indexes, and they are surprised. However, if I do the opposite manipulation is very simple. We start with the telephone behind my back, and then when I go away, then I take it out, right? I take it out, the telephone goes away. However, you still see my hand here, and now there is another telephone coming up. So this is the unexpected appearance, right? Where you have to encode that the object is not there. So you have to form a negative representation, right? You have to encode that the object is not there. And you have to be surprised if you see the object there, right? Because it's incompatible with this representation. However, what is found in several studies that infants do not represent the absence of object. They represent very well the presence, but they do not represent the absence of object. And the question is why? Of course, present as absent are encoded by different systems. One can be very easily encoded by the object tracking system. However, the object tracking system cannot encode the absence of objects explicitly, right? So if this was here, now I remove it, then if you just use the object tracking system, you take the index and you move it away or you delete it. But that's not an explicit representation of absence. That's the absence of a representation. I don't know if the distinction is clear, but however, but I'm just noting this, that there must be another system which encodes the absence of objects, which cannot be the object tracking system, and maybe is the language of thought. Okay, but then how can we study this, and how can we study whether young infants already understand negation and can use these negative concepts early on? And one way to study this, which we thought, of course, again, we start with language because that's easy in a way. And what we wanted to do there, we wanted to study whether infants have a proto-negation, when infants start learning language. This is not very early on, you shouldn't think about newborns, but let's say when they produce language, start producing language, let's say at 12 months or 18 months, do they start with a proto-negation concept? Do they start with some weird representation of negation or absence? Or do they have fully fledged negation? And how can we study this? The idea which we had, we take two forms of negation, which are present in infants and in some languages. And the idea is, if these two forms emerge at the same time, it's likely that they are founded by the same kind of abstract negation, especially that one of the negation sometimes is claimed to be not negation or proto-negation. So let me explain what I mean. While negation seems to be very complex, and I try to argue that it's not trivial how we represent it, those who have children know that one of the first words which infant says is no. However, this refers to rejection, like no milk, not wanting to do something. And while the infants use the word no very early on, it was argued in the literature that this is not used in a propositional, in a truth functional sense, right? This is used as a word island, and we don't know what it maps on. It maps probably only on rejection, but this is not truth functional in the sense that they can use no to negate any possible proposition. And this is called the conceptual gap hypothesis, that early on they start using no, but that's not the fully fledged negation, that's something different. And then there is a conceptual development, and then it comes the fully fledged negation. And just to illustrate one study how this is studied, this is a study by Roman Feynman, Susan Kelly, and collaborators. And what they find, that in comprehension, understanding propositional negation comes very late. While at 12 months, they might say no, at 27 months, they are still not very good in understanding propositional negation. So this is a task in which you hide an object in the bucket or in the truck, in these two things, and then you tell the toddler, the object is not in the bucket, and then you measure where the child is searching for the object, right? And what they find that at 20 months, they are below chance. So they interpret negation as affirmative, actually. But the problem with this task is that also with the affirmative, they are very bad. So they are around chance at 20 months. So if I tell you the object, the ball is in the bucket, you still go a little bit random. And then this reveals that there might be some problem with the task they use, or there might be some problem with understanding the affirmative language. According to the second possibility, of course, negation has these strong mapping issues, right? There is an abstract concept, and there's also it relies on affirmation. So there are theories of negation which claim that first, before you interpret a negation, you always activate the affirmative version, and this introduces different biases. However, what we wanted to ask here, whether if there is an early fully fledged negation, then different forms of negation should appear at the same time in young children. And it shouldn't be the case that some forms of negation, like rejection or, for instance, non-existence, like all gone, also appears very early on, but is also claimed that all gone is not a negation term, and it's like a proto-negation. then if the conceptual gap hypothesis is true, then there should be some negation form should emerge early and would be proto-negation, some others should emerge later. And this is what we aim to study. And we were lucky that we have a native language, which is Hungarian, in which there is actually a negation, which is called existential negation, which is equivalent to all gone, except that all gone is not a negation, but in many languages except Hungarian, there is an existential negation, which actually is like it is not with the meaning of all gone. And it is a single word like nincsen, but it can be used in a variety of contexts, like I don't have money, there are no unicorns. So it expresses the non-existence of money, unicorns, objects at location. It can be used in all these senses. Therefore, it's much broader than all gone, and it's a negative term. And we compared these sentences which contain this to propositional denial, which is nemitron, which corresponds to it is not here, which would be negating the fact that the object is here. And what we wanted to see, whether these two kinds of negation emerge at the same time or one emerges earlier, which would be evidence for this proto-negation. Okay, so how is the task? The task is a two-cup task with a call task with with an invisible hiding, which you see here. And then so I hide the object somewhere. Then I look into one of the containers and I say, it is not here. And then, of course, what the infant is expected to do, to go to the other. Note that this involves also like disjunctive syllogism, right? So A or B, not A, communicated via verbal propositional information, and you should go to the other cup. And we tested these two forms of negation, the existential and the propositional. And this is just an example, but maybe on due to the lack of time, maybe I will skip it. So this is just a hiding, and she says she provides negative information about the other. She just lifts the other to the other cup in order to equalize salience, and then the child is allowed to search for the object. Okay, and what do we find here? So with both meaning of negations, we find that 18 months old, they pass both. So they pass both this organ kind of negation, which we predicted, which both theories should predict that they should pass, but they also pass this truth functional negation version of negation, which is the dark bar, and there's no difference between the two, which to us, it suggests that early on, different kind of negation likely map on the same concept, and this is present from the very first trial, right? So it's not that infants can learn throughout the task that what this negation means and what these terms means, but they do it in this way. Okay. However, this conceptual gap, one might argue that it might be present earlier, and one might argue that, well, maybe 15 months old, for instance, would be good in with one negation, the existential, the proto-negation concept, but would be bad with the other. But this is not what we find. So at 15 months, they fail both. So at 18, they succeed both, and at 15, they fail both. So as soon as they map any negation concept to language, they seemingly map both, and they can use both. And if they cannot use, they cannot use any. And of course, we also did a nonverbal check to see whether it's not the task difficulty which 15 months old fail. And we just show them we show visual information that the cup is not there. And they pass that. So if you don't have this mapping issue that you have to map negation or the concept of empty or the concept of absence on something, then they do pass this task. I see that I'm doing very badly with time, but maybe I just mention, I had this other line of studies on thin gist in infants, but maybe I can talk about that in separately if someone is interested. I just mentioned one more point and I finish in 1 minute. Is that okay? Okay. Okay, so I just want to mention this ongoing study on negation, because this is nonverbal negation now. Because of course, if we find evidence that they map this fully fledged negation at the same time. We don't have this concept of proto-negation. This also implies that young infants should have nonverbal negation much earlier, and we should be able to tackle on that somehow in the visual domain, for instance. However, as we mentioned, negation is not very trivial because, for instance, negation, when I say it's not in the bucket, I mention always the bucket, you activate the bucket. So there's always this saliency bias or iconicity bias. And similarly, if I try to implement this negation in a nonverbal task, like it was done by Isabelle Dautriche and collaborators. So if I use a stimuli, let's say this, now I cannot point there because I don't see it and you don't see it either, sorry. I don't know how to make this go away, but let's say you have an icon and then you mark negation with a cross, very simple. However, what they find that baboons take 1,500 trials in order to learn that this get rid of this matching, that cross matches to cross, and I should choose the cross when I see a cross. Sorry, I should choose the symbol which matches the symbol, and this little cross means actually negation. So it takes lots of training. However, that's also true for infants. So first meanings of negation seem to be affirmation. So it's very difficult to neglect this the argument which is mentioned in with the negation together. So what we thought, and I wonder what you think about that. So what we thought in the visual domain, actually to introduce two markers. We introduce a marker for the negation, which let's say this very simple lines would be a negation marker. However, to make it salient and make it easier to learn, we also introduce a marker for the affirmation. Now, those people who work on language will say we are completely crazy. There's no affirmation marker in language or in anything. However, that's not our problem, right? So if we don't start from language, and it's possible that it's actually much easier to learn some markers when you have a marker for negation, a marker for affirmation in vision. And we shouldn't start from the assumption that in language there is no marker for affirmation. Maybe in the visual domain, this actually would help us. Unfortunately, I have no data on that, but that's the intuition that in the visual domain or the language of thought in geometry or with objects might be very different and shouldn't be the same as the natural language. And with this, I will actually finish because there won't be. So this is the scene study, but I can, yeah, I finish here maybe. Thank you. Okay, thank you very much.
Thank you very much. Very rich, and apparently you are much more present. Is there any question in the room? So I will answer